In this video, I would like to focus on one topic, which is reasons for database normalization. Normalization, I explained it before in a previous video when we did talk about the dependencies, and we mentioned that uh, normalization is to create a database tables in the preferred third normal form so that we can actually get rid of what we did call at that time partial dependency and transitive dependency. I would like to make it even simpler today by um, explaining some more reasons for normalization. Basically, I would summarize them in three reasons, which is to minimize data duplication and to minimize the modification issues because database usually is not static. It has to be changed all of the time. The database in any company or any organization keep changing. So to minimize or avoid a lot of different modification issues, we need to think of normalization as a solution for this problem from the beginning before we actually construct our database. And the third reason is to simplify queries, to make queries from the database more simpler, straightforward, and more convenient. As we actually go from one state of normalization to another, we can discuss how this each form addresses these issues. But let us start with simple data that that is unnormalized data, and to discuss some potential pitfalls or problems arising from this data. I think once we understand this, these issues, then we can actually appreciate how normalization is important. So I would like you to look at this table. This table is a very small one. I decided to make it smaller so that you can actually focus on the data and understand the values inside the table so that we can actually talk about the problems arising from this data. As you know that this is a primary key here. Employee ID is underlined. What do you notice from this table? Once you look at this table, you will find that there are many purposes for this table. This table is not storing only information about employees or salesperson or the customer. They store information about all, about customers, about offices, about salesperson, about employees. So there are many purposes that we can summarize them into these four. This table identify the organization salespeople, so you can actually see these guys are salespersons. And also it lists the sale offices here, the names of the sale offices in this column, and also their phone numbers. The same table associate a sales person with a sales office. So every salesperson has a sales office. So it links every sales person with a specific sales office. Also, the same table show each salesperson customers. So this is customers that are assigned to some sales persons. So there is many purposes. From the first glance, you can say that, oh, this table actually can serve a lot of good stuff. But in fact, it has a lot of potential problems that we will discuss in this tutorial. First thing that you will consider as a database, this will raise a very big red flag. as a database administrator or a database designer, I would like to see that every table has a specific purpose. So if there are employees in the organization, then the table contains employee information only. All the information: employee name, first name, last name, date of birth, age, salary, job, whatever. And all salespeople should be stored in another table that concerns only the salespeople. Also, sales offices should be in a specific table, contains about sales office name, office number, location, state, and so forth, address, and so forth. Also, if I have customers in the organization, I would like to see all customers are contained in one table. So all information about customers are grouped together in one table. Because having a table like this serving many purposes, it will introduce many of the challenges, namely data duplication. So data can be duplicated unnecessarily, and also it will increase the effort in retrieving data when we would like to query the database. What can arise from this? We call it anomalies. Anomalies is not desirable situation in database. The word anomalies will, in this case, the problems arising from this table, we call them modification anomalies. Modification anomalies or problems. So the database term we use in this respect, we call it anomalies. We have three different anomalies, as we will discuss in a minute. These modification anomalies that I would like you to look at, for example, a salesperson. We have listed the sales office and also office number. So there is a duplicate salesperson data because the information are repeated here. Like you see here, for example, this phone number is repeated twice. It has to be stored here and here. This is a very small table, guys. But if you have really many employees and many sales people, they have like hundreds of them, then you will see this office number is repeated many times. Every time you see sales office Chicago, you will see the same phone number, 312-555-1212, and so forth. So this will increase the storage and also decrease the performance, and it become more difficult to maintain the data kinks. So if I would like to make the kinks, I have to make the kinks in all records in the table. If there is any change in one of these phone numbers, for example, this change, I have to make the change multiple times. So this is called modification anomaly. In this example, it is update anomaly. Modification anomalies, basically, if we, for example, also consider moving the Chicago office to Richmond, Virginia. I would like to move this Chicago office to Richmond, Virginia, as an example. So how do I reflect this in our table? We need to update all entries for this sales persons. Every salesperson who has been assigned to Chicago before, now he has to be reassigned to Richmond. If we have many entries, this also can involve hundreds of updates that is required to be modified. This situation, it is called modification anomaly, as I explained earlier. But the database normalization will fix this issue. Database normalization, that means dividing our tables into many tables instead of one and have relationship between them, and this is called normalization, make things normal. There are three different modification anomalies that can occur. I can list them into these three different anomalies: insert anomaly, update anomaly, and deletion anomaly or delete anomaly. Let me start explaining the first one, which is insert anomaly, and I would like you to understand it by looking at the table. There are some facts that we cannot record until we know the information for the entire row. For example, I would like to add a salesperson, new salesperson, and I would like to put this sales office in Atlanta with a specific phone number, for example. I cannot do this without adding an employee. So I cannot actually add a sales office without assigning an employee to it. So simply, if I'd like to create a new record, we need to provide the entire record, right? Employee ID, salesperson, sales office, office number, customer 1, customer 2, customer 3. But I don't have employees. I would like just to create a new office. In this case, I cannot create a new office without adding an employee. Why? Because the employee ID is a primary key and I have to insert it. If I cannot insert an employee ID in this table, I cannot insert the rest of the records. So I have to add employee. So I have to make up an employee so that I can add an office, which is not right, which is not convenient. I mean, consider that a company wanted to add a sales office and assign a salesperson for that office, but they don't want to, they don't want to add, I would like to add a sales office and give that office a number and everything. They cannot do this without providing some information like employees for it. And also, of course, customers, in case customers are not null in this table. But I can get away with all of this, all of them, except the employee ID. I have to provide the employee ID. Why? Because employee ID is a primary key and has to be inserted. So the insert anomaly simply talks about the fact that if you cannot add a record without adding unwanted record or unwanted information, this is called insert anomaly. Simply, in order to create a new record, we need to create other information that is not basically required. So this is called insert anomaly. Another example for this anomalies is called update anomaly, and this is very clear, which is in this case we have the information already in the table. But for example, if I would like to change some information for one of the records, then the update should actually take place in all of the records that need to be modified. So if we don't update all rows, then inconsistency will appear. As I told you here, for example, look at the office number. For example, Chicago office, change their number to another number. So every time you see Chicago here, you have to go and change that office number. So if Chicago appears here, like for example 50 times, then you have to make the 50 change for the office number. This is called update anomaly, in which multiple updates are required to be done in case one of the information modified, which is not desirable situation, because this will be time consuming and will be inconsistent sometimes, especially if you enter one of the phone numbers wrong, for example. That might create a problem. The last one is called delete anomaly, which is the deletion of a row that causes the removal of more than one set of facts. Like for example, if one of the employees retired, assume that John Hunt, this guy, he retired, or he moved, or he resigned, or whatever, he is no longer with us. I would like to remove him. How do I remove him? I remove him by removing the entire row, right? And then if I remove the entire row, I am removing also the office New York and these customers here. So I will lose information that I have an office in New York and it has a phone number and it has customers. I will remove everything in that row, so I will lose some information. So simply, deletion anomaly is when you delete unwanted information, then you lose some important facts in your table, which is not desirable situation as well. So now we did talk about three different anomalies. The insert anomaly, which is if we cannot insert new record without inserting other information that is not required. Update anomaly is the need to make multiple modifications or change in one of the columns in case the information, one fact of information has been changed. You have to do multiples, different and many different modifications following that change. And the last one is delete anomaly, in which when you delete unwanted information, then you lose information about other facts. For these three different problems, then we need normalization. So normalization is a database design by which we will fix all database anomalies and also the dependencies as we explained in the previous video.